Bismillahirrahmanirrahim. Assalamu alaikum dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about structure of amines and imines according to hybridization. And in this video lecture, we will discuss the examples of amines, that is CH3NH2 methylamine and CH2 double bond NH as an example of imine. But before moving forward to explain the structure of these amines and imine compounds, we will discuss structure of ammonia molecule according to hybridization, because it would make the concept to explain the structure of these compounds easier. So now let's begin. So first of all, we see the structure of ammonia molecule. As you know that the atomic number of nitrogen is 7, that is 1s2, 2s2, 2px1, 2py1 and 2pz1. And if we draw all these atomic orbitals according to their energy level, then it becomes like this. The energy level would increase from bottom to top. Here at the ground state, 1s orbital would contain 2 electrons, 2s would also contain 2 electrons, then 2px, y and z. So here each of these orbitals would contain 1 electron in each. So all of these degenerate p orbitals would contain 1 electron in each. Here this shows the energy level and this is the ground state electronic configuration. As these p degenerate orbitals, all of them contain 1 electron in each. So in the case of ammonia, as you know that here the ammonia has 1 lone pair of electrons and 3 hydrogen atoms. So in this case there are 3 and 4. So total 4 orbitals are taking part. So for the sake of this, all of these orbitals would intermix, and in the case of intermixing, they would generate 4 equal in energy and with same shape. These would be sp3, as here 2s orbital and 3 degenerate p orbitals are intermixing together, so that there would be 4 sp3 hybrid orbitals. And as here the total number of electrons is 3 and 2, 5. So we have to arrange the 5 electrons in these 4 sp3 hybrid orbitals, and 2 electrons would be in sp3. Either you may place 2 electrons in any of these sp3 hybrid orbitals, but only in one sp3. Amongst these 4, only one sp3 hybrid orbital would contain 2 electrons, because you have to count the number of electrons as well. 3 and 2, 5 electrons. Here these 4 and these 5. The total number of electrons would remain same. The total number of electrons would be 5 in these 4 sp3 hybrid orbitals, and the 1s orbital would become as it is. And this is the case with hybrid orbitals. So now we have to orient these sp3 hybrid orbitals in such a way that there would be minimum repulsion amongst themselves. So here there would be one sp3 hybrid orbitals, there would be another one, here. So in this way there are total 4 sp3 hybrid orbitals, and as in the case of ammonia there are 3 hydrogen atoms and all of the one has 2 electrons. So this one would have the 2 electrons and that would become like a lone pair. If we draw a simple structure of ammonia, then this lone pair of electrons would orient here, and this sp3 orbital has 1 electron in this would also has 1 in each, and each of these 3 sp3 hybrid orbitals are overlapped with 1s orbital of the hydrogen, and when this would overlap with the 1s orbital, then this 1s orbital would also share its electron with the sp3 hybrid orbital. So in this way, here there would be a bond pair with hydrogen. So here there would also be a bond pair of electrons. Here there would be also a bond pair of electrons with the hydrogen. So in this way, there are total 3 bond pairs with hydrogen atom and 1 lone pair of electrons, that is this one. So in this way, this ammonia molecule undergoes sp3 hybridization. Now we move towards the structure of nitriles, taking methyl nitrile as an example. Here there is CH3, CN. This is methyl nitrile. So here okay. So in the case of amines, that is like CH3, NH2. Here the nitrogen atom would undergo sp3 hybridization in the similar way as we have gone through, and CH3 would also show the identical behavior as CH4. There was sp3 hybridization as you have studied in the case of methane molecule. The only difference is here one hydrogen would be replaced with the nitrogen. So there would be 3 hydrogen atoms with the carbon and the other sp3 hybrid orbital would overlap with the nitrogen. So in which manner it would happen? In the case of carbon, there would be 3 here and 1. As this is the saturated one, methyl group has no double bond in it. So that shows there would be sp3 hybridization. So in this case, this is also sp3 hybrid orbitals, and these are sp3 hybrid orbitals of the carbon atom, and all of these have 1 electron in them. The structure of methane has been discussed in the previous video lectures. So the link has also been given in the subscription below. So you may also find out the video lecture regarding structure of methane according to hybridization. So here these 1, 2 and 3, these 3 sp3 hybrid orbitals would overlap with 1s orbital of the hydrogen making the CH3, that is here this CH3. And now this sp3 hybrid orbital would combine or would overlap with the sp3 hybrid orbital of the nitrogen, because it is also in the same way as NH3. The only difference is the one hydrogen has been replaced with the carbon. So in this case, here one sp3 hybrid orbital has overlapped with the sp3 hybrid orbital of carbon, and this is the sigma bond. This is also sigma bond, this is also sigma bond, and this is also sigma bond in nature. And now there are, this is the one sp3 hybrid orbital containing the lone pair of electrons, and these two sp3 hybrid orbitals would overlap with 1s orbital of the hydrogens, and here it would also be sigma in nature and it would also be sigma in nature, but this one resides as a lone pair like this. So in this way the structure is like carbon and single sigma bond with nitrogen. Here there are two hydrogens attached with nitrogen as this and this ones, with one lone pair of electrons that is shown here, and there are 3, 1, 2 and 3. 3 hydrogens have been attached with this methyl group. So in this way the structure of methyl amine has been explained according to hybridization. Now we move toward the structure of CH2NH. So in this case, this CH2, and here there is a double bond with the nitrogen, and nitrogen has one hydrogen. So in this way, as it is unsaturated in nature and looks like the structure of ethene or alkenes, CH2. I am talking about the CH2 that looks like an alkene. And you know that in the case of alkenes that follows sp2 hybridization, and as you see the nitrogen, as it is forming 2 sigma bonds only and has one lone pair of electrons, so there would be 3 hybrid orbitals. It has the atomic number 7, 1s2, 2s2, 2px, 2py and 2pz. So both of these have 1 electron. So in this way this 2pz orbital would be unhybridized, and these 2s, 2px and 2py atomic orbitals would hybridize to form sp2 hybrid orbitals in the case of nitrogen. So in these cases where there is a double bond between carbon and nitrogen, both of these atoms, carbon and nitrogen, would follow the sp2 hybridization. So in this case, these sp2 hybrid orbitals would make a geometry like this one. In the case of carbon, as there are 3 hybrid orbitals that are sp2. So all of these 3 have 1 electron in them, 1 electron in each of them, and there is one unhybridized atomic orbital, that is 2pz. This is in the case of carbon. And similarly, this carbon has 2 hydrogen bonds, 2 bonds with the hydrogen. So here this hybrid orbital sp2 would form or would overlap with 1s orbital of the hydrogen. It would also overlap with 1s of the hydrogen. So in this way, there would be 2 sigma bonds with 2 hydrogen atoms. Here 1 sigma bond with the hydrogen, and the 1 sigma bond is here with this hydrogen. So now there is 1 sigma bond with the nitrogen and 1 pi bond with the nitrogen. So this sp2 hybrid orbital would form a sigma bond with the nitrogen, and the nitrogen would also have 1 sp2 hybrid orbital, and that would overlap with this sp2 hybrid orbital of the carbon to form the sigma bond. And there are 2 other hybrid orbitals that are sp2. So one of the sp2 hybrid orbitals of the nitrogen would have electron pair in it, and one of the sp2 hybrid orbital would have the 1 electron in it, and this would also has 1 electron in it that has been paired up with the sp2 of the carbon. And this sp2 hybrid orbital of the nitrogen would combine with the 1s orbital of the hydrogen to form a sigma bond. This is also it is neither sigma or nor pi bond, but it would be shown as this lone pair of electron. And here there is also a 2pz orbital of the nitrogen, and this would overlap with the 2pz orbital of the carbon to form a pi bond. That has been shown drawing an other line above the sigma bond. So in this way, the structure of imine or CH2NH has been explained. So now we move towards the HCN and also the methyl nitrile in the next video lecture. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.